Hi, this is my second video all about functions in Python. In my first video I didn't put in anything about function overloading or monkey patching, which are quite important in my opinion. Now, function overloading allows you to have a function that does different things depending on the argument or arguments passed to it. And I've already discussed function aliasing, which among other things is really useful for debugging. But monkey patching, I didn't actually know that what this was when I was doing it, can be used when testing, and also it's quite useful. Well, I've got a really bad internet connection, really slow, and sometimes it isn't there at all. So what I sometimes do is I use an API and I save sample data, and then I can use it when I'm writing my program, and I don't have to rely on the internet. And then when my program is doing what I want it to do, then I run it properly, using the API call. And it's quite good if you've got a limited number of API calls in a certain length of time, or you're having to pay for them. And another reason for using monkey patching is you can extend or change third-party code without having to make a copy. Right, I think that's about it. Now, when I've made videos before, when I haven't used the camera or anything, I was just using the Thonny window, I just recorded the area of the screen that was the Thonny, that, if you can see that right-hand window. But unfortunately, YouTube, if you do that, I couldn't get it to go to HD quality, so I thought I'd have both windows showing, which is a bit annoying and isn't as big, but at least it's better quality. So I'm working on the right-hand window, but I'm copying in the code from the left-hand window. Right. So first of all, this is all about function overloading, by the way. Right, this very simple function, it takes in an argument, and if it's a string, if it's an instance of the string, it says this is your string, and if it's an integer, it says if it's the integer. But this could get really, really, really ungainly, because it's all linear. You'd have this if instance of whatever, and that's a better way of doing it. But there you go, it works. This is your integer, this is your string. But instead of using that, you can use function overloading. And first of all, I'll just show this bit of code. Now, you import is included in functools, so there you go, import single dispatch, and then you just do that. That's a decorator on your function, and your function just takes in arg, we could call it anything, and I've just put in verbose equals false there for the sake of it, and it will call that function if you haven't defined the behavior for the type of argument. So at the moment I haven't put any behavior in for anything, so that is what it will call it. So I'll just go func of 42, for example, and then it says not implemented because it says print not implemented. You can also raise an error if you wish. There it says, I don't know how small the writing is for you, it says not implemented error, type blah blah int, cannot be used with func. Well, that's because I haven't defined it, but it's actually easier to just print it and not do the error. So then you can define the behavior depending on what the arg is. Therefore, you've got this at func.register for string, and those bits there are the same as those bits there. And the convention is, because that def blah blah doesn't need a name, you just put underscore rather than putting a name for it. What's the point of giving it a name if you don't need it? So it just says if it's verbose, you print out something long, otherwise you just print out string whatever. And of course we need to put the right thing in. Yeah, we'll run that. And there it goes. It goes string cat. String cat, because verbose wasn't true. And you can go comma verbose equals true. And this is your string. So you've just got one bit there to deal with strings. But you can add more. So we'll add something for integer. There. Exactly the same, only this time it only gets in there if it's an integer. If the arg there is an integer. So we'll put 42 there. And again, you have verbose equals true or false. So there we go. This is your integer. That's what we wanted it to do. Or if you don't have the verbose equals true, but you do need a bracket. There, integer. But you might want to do something else. You might want to do it for float as well. So because at the moment, if we run it with a float, not implemented, even though that is an integer, if you know what I mean, it's a round number. So we will put the thing in for float. Yeah, that works wonderfully. But you might not want to have the same, to have a bit of code there, excuse me, for int and a bit of code there for float. You might want to do exactly the same thing. So what you can do is you can put more than one of these func register things. So you've got func register int, func register float, and get rid of that. And I suppose there you want that to be number and number. Like that. Right, number equals 42.0, and then you can go still, whoops, helps if that is, goodness sake, I had caps lock on, not caps lock, but I pressed the shift key in the wrong place, right, there. So that still works for integer and float. But there's another way of doing it, which I actually prefer. Just you can import from numbers, import number. Up here, from numbers, import number. And number is a type. You know, like string is a type, and int is a type, and float is a type. So instead of having those two lines, you can have func register number. And as if by magic, that works as well, which is great. So you now have something. I may as well take out those two. You now have something that copes with strings and something that copes with numbers, but you might want to have something for kind of collections like lists, tuples, sets, whatever. So you can do the same thing down here. So I've done this func register for list, tuple and set. There's the verbose equals false thingy, and then it just prints them out in the length, or it just prints it prints out what it is. So what can we use? I've got a couple of examples here. Try that one. That's a tuple. Right, it says this is it's a tuple with 4 elements, 0, 1, 2, 3, which is what I did. Then you can just shove the whole lot in, really. There, you can do all sorts of things. You've got, you'll then have a list, a set, a dictionary, a tuple, non-verbose. So you've got all sorts of combinations there. So what it does is, this is your class tuple with 4 elements. Yeah. This is your class list with 3 elements. Yeah. This is your set with 5 elements. Yeah. Then that is a dictionary, but it isn't implemented. Then we've got the non-verbose things for tuple, list and set. So that all seems to be working well, because that just says this is your type dugug. So that arg, that type of arg, it knows that that is a list or tuple or set that you've passed in, if you get my drift. And you can add one for a dictionary if you so wish. That dictionary, this is your dictionary, blah blah blah. Won't bother to run through everything. There, works perfectly. That's a dictionary. Now, if you wanted to use more than the arguments that you've got in there, so I've just got one argument and verbose. It's all driven by the type of that argument. But you can put extra arguments in, and if you still want the verbose, you just put in something like, if you put in that is, you've got your first argument, then you've got any number of extra arguments in the middle, and then it has to be a keyword argument at the end for verbose. So you need to add that in all of your definitions, and it ought to work like that, like that, like that, and like that. That ought to work. Yeah, so we'll run it again. Excuse me, that's just a verbose dictionary. Yep, that still works. And you can change it so you can add other arguments. So you've got your dictionary, and then you can just have cat dog, for example, and of course you aren't doing anything with those extra things, so you could put here print no, don't need the star. There, that works. That works because it's actually finding them. And if you want to do that, if you want to use the extra args that you can put in anything, you have to put something in, if you know what I mean. I've only put that in for if verbose, then I'm printing out the extra arguments. But you can do something with extra arguments in here, say. You can print the extra arguments in the string. So if we're running the string, we just go func cat, comma 12, comma 13, comma 14, and that ought to work. Yeah, so you can pass in anything that you want in your extra args, and it appears in a tuple that is passed to it called extra args. So that's about it for single dispatch. So single dispatch is really good for doing function overloading if you only want to consider the first argument that you pass, like string, or that's a big long line, or int, or number, or whatever. But if you want to, say, have a function that could take two strings, or a string and an integer, or anything like that, then you have to download something written by a third party. So if you go to Tools, Manage Packages, and then you go multiple, oh, that should be about enough, multiple dispatch. Right, I've installed it already, but you can just install it and then use it. Now, you mustn't confuse it with multi-dispatch, which was a version from I don't know how many years ago. I don't know whether it's still around, but it wouldn't work the same. So to use it, you can just do something like that. Import dispatch from multi-dispatch, and then I'm using numbers again. Oh, shush. And then to use it, you just have this decorator thing, and the default one for not having implemented whatever you want down there. It's just easiest to go object and object, because everything's an object, and then as before, you just print not implemented, and then you can define your own ones. So there you go, number. You can add things like the verbose, and you can add extra the extra args, or actually define the extra args, but this is just the basics of it. So if I call multiply with two numbers, I just multiply them together and print them out. And if I call it with a string and a number, I just say there are that many whatevers. So I just run that. There are 5 cats. Not implemented was cat and dog, because cat and dogs fight. And then multiply 2 times 6 is 12. So that's just a quick look at using multiple dispatch. Now moving on to monkey patching. Monkey patching is a term that I've only recently heard, and I hadn't realised that I was doing this, and other people did it as well. And it's when you take an existing function or module or class, etc., and you dynamically replace it or alter it or extend it with something else. And it's very useful for testing, and I use it for when I don't have internet access. If I'm using a program when I need to get things from an API or whatever, and I don't have internet access, I can just spoof the data so I can test my program, and I get it working and then use it with real data. It's useful as well if you are paying for API calls or you only have a limited number, whatever. So here is, and you can use monkey patching for your own functions, etc., built-in functions or third-party ones. So here is a very simple program, which is just, there's a list of animal names and I'm choosing a name at random and printing it. There, Trump. Run it again, Mr. Todd. Run it again, Zarafa. Now that is so simple, but you can overwrite random choice with something else, as in, I will just show you this. There. Ignore that line for the time being. So I've written a substitute function. So I'm doing as I did before, and then I've said random choice is going to be overwritten by my substitute function. So instead of choosing an animal name at random, it will just return, it will replace random choice by that, and it will just return Keith. So we'll run that. Right, so it's Hugo, Keith. Run it again, Frankie, Keith. Frankie, Keith again. Hugo, Keith. We need more animals. Zarafa, Keith, yes. So that's what that does, and it doesn't change random choice, the source code of it, at all. But what you and when you've run that program, when you run it again or run another one, random choice has actually reverted to what it was in the beginning. But if you're doing something in the shell, you want to make sure that you haven't left it over like that. So what you can do is up here you've imported import lib, and then you can just go reload random, so you're absolutely sure that it is still as it was. I didn't want to do that. Right, try again. There. So there we go. Hugo at random, Keith, and then it's changed back to the proper function. Run it again. Yep. And sometimes people will use this monkey patching in an import in one of their libraries. So you can go import something or other, and then within their code they could be doing something like that. Not a random choice, that'd be stupid. But then you could import another module and it could be overwriting that with something else, and it's kind of the last one wins. So it really isn't a good thing, in my opinion. I know people would do it, to overwrite it in production code, unless you really know what you're doing, and you might just be extending the code. Like if you really had to use a library but it didn't do as much as you wanted it to do, you could just add on a bit and it would just add another function to it, or it would be a method to it, and everything would be okay. So that is the basics of it. But I have a program here that this is just using that API call to get crypto prices. So we'll run it. There, wonderful. But in my program, I'm wanting to test it, but I don't want to have to keep using the API call, because I might be somewhere where I am somewhere where the internet's rubbish. So you can spoof the data. So what I've done in programs is I've just put in here that line. I just print the crypto prices like that, and there we have, that is the data that is coming in from that ufile.read. And what I've done is I've saved it to another function. So I will show you what I've done. Instead of that original program here, I've started off testing equals true, which is where I'm overwriting that get crypto prices, or if testing is false, it just worked exactly as it worked before. I don't need to do that. And I've taken the values that I printed out there, and I'm just returning them in that get fake crypto prices. So it comes along and it says, right, here we go, testing is true. If testing get crypto prices equals fake crypto prices, so that is doing a monkey patch. So instead of calling that down there, it's calling that, and you can see that it is working properly. If we run it, if you see, that's 88603 for that, right, 88603. So that is doing exactly what I said. It's overwriting the function. And if you put that in as false, that is no longer 88603. And as well as saving on your API calls or doing things when you don't have the internet, it helps you test every branch of your program, so that you can test whether it works on a Monday, Tuesday, Wednesday, Thursday, Friday, etc. Or you can test whether it can cope with the 30th of April. And it kind of would have been a good thing if Paul had used this before he made his GPS video, the last one, because he hadn't tested properly at all. And then there's just one other thing you can kind of do. I will get rid of all that. Oh, I want my animal names. They're animal names, and you can just go print min like that. Print min animal names, and it prints Frankie because that's the first alphabetically. And you could go print Matt's animal names, Zarafa. But you can put in a monkey patch, so you can go def mini. No, I didn't want that. Whoop off arg return mouse, for example, and you can do the same for maxi. Maxi, and you can return elephant. So that is returning something that isn't in the list at all. So return mini, return maxi. Run that. There. That is the first alphabetically, the last alphabetically, and then we've got mouse and elephant. But even though that is a built-in function, you can override it. Like up here, you can go min equals mini, max equals maxi. So I'm not explicitly calling mini or maxi, but it will still work. Right, so it says print min, but min is now mini, so I'm printing mini mouse. That's just to show that you can do it with built-in functions. And you can also do something really, really weird, but I don't know why you would ever want to do this. You could go min stroke max equals max stroke min. Don't want that bit. And it works. It works. Oh no, that's max stroke mini. No. Right, try that again. Right, there we go. So we're printing min, which is now max, and we're printing, yeah, so you can do some pretty silly things, but it's very useful in certain circumstances.